the recording. So basically, in the previous where we discussed about different types of equipments or different types of apparatuses that are being used there, the important question is why the accuracy and the precision is needed. Because in the previous lecture, I have told you that it is very necessary that you are going to use the very right equipment for the experiment, for the concerned experiment. For example, this example I have already given you that if you are using, let's say, the thermometer to measure the temperature, and the requirement of the, let's say, the experiment is probably you are going to measure the boiling point of, let's say, water. You are boiling the water and you are going to measure the boiling point. What would you do? You need to have thermometer which is precisely accurate. I am using the word precisely accurate. I am using this term together: precision
Yes.
and accuracy. Precisely accurate. One thing is accuracy, means this is exactly accurate. The other is precisely accurate, means let's say you can, because precision is basically when you are measuring the measuring different values, you have different basically calibrations over to the equipment or over to the apparatus. I can give you the example of scale. If you are, let's say, measuring the values in centimeters, there are, let's say, 1.5 centimeter, 1.6, 1.7, 1.8, 1.9, and then 2. That 1.8, 1.7, these calibrations in decimals is basically giving you the precision accuracy, precisely accurate. So because if you are moving from
Oh,
1 to 2 directly without calibration over the in between calibration over there, so let's say if the reading is between 1 and 2, how would you suggest, or how would you get to know that the reading the result is 1.5 or 1.6 if the calibration is not there? So this is called precisely accurate. So you are, let's say, having a thermometer. You wanted to measure the temperature at which the water boils. So what would you do? You need to have a thermometer in which at least it can measure 100 degrees Celsius. But obviously 102, 103, 104, like above 100 degrees Celsius, it should have a range of measuring temperature. That would called as precisely accurate. In the example discussed in the book, he says that acid based titration example, like the true volume of acid, if you are what you are needed to neutralize, let's say 25 cubic centimeters of alkali, it is basically required as 14.10 cubic centimeters. That means 14.10 cubic centimeter of acid is going to neutralize 2.25 cubic centimeter of base. So when you are carrying out this experiment, the let's say you are carrying out this experiment, the values which are recorded is 12.45, 12.55, and 12.5 cubic centimeter. So what is happening here? This is basically precise data, and there are repeated values that are being shown with, let's say, 0.05 of the difference: 12.45, then 12.55, sorry, then 12.5, and then 12.55. Basically, we have multiple times repeated this experiment. Multiple time repeated this experiment, but there is a very small difference. But there is a very small difference in the answers. Is it?
yes.
So, but we cannot say that these are accurate. We cannot say these are accurate values. Let's say there is some other student which is going to repeat the same experiment, and the answer is 14.3 cubic centimeter, then 14 cubic centimeter, and then 14.1 cubic 15 cubic centimeter. Now this data is not precise because the difference in the average values, it is quite larger. So what would we do? Look at this diagram. This is accurate as well as precise. This is not accurate but precise. This is accurate but not precise. And obviously these are very, the difference is very larger, as well as from the target values they are very much far. So we would say that this is obviously not required result. You must have minimum difference, number one. Look at this, the difference is quite minimum. Number two, it should be very closer to the target. It should be very closer to the target. Then you would say that it is precisely accurate. Like if you are measuring the boiling temperature, the boiling point of the water, and you are continuously having the same values, let's say 100, 100.01 and 100.02. So obviously you would say the values are accurate and they are precise as well. This is called accuracy and precision of the data we are recording here. Then we would discuss what is repeatable and reproducibility. What is repeatable and reproducibility? uh, these things we have discussed multiple times in different types of scenarios. One thing you should know that like these topics, accuracy, precision, repeatability and reproducibility, the questions from this type of theory, it's normally it is not likely to ask, but yes, they are going to be applied into the separation techniques. So you must have an understanding of these topics as well. That is why we are going through these topics. Obviously they are included in your syllabus, but yeah, the analysis part is normally, the question part is going to be related to the separation techniques. Mostly the examiners ask question from the separation techniques. So when the chemist, like you are chemist, so you are going carrying out the reactions, what would we do? Obviously you are going to consider different types of factors that are going to affect your results. So what should we do? The data we have, it should be reliable and reproducible as well. Reliable and reproducible as well. When it is reliable or repeatable? When it is reliable or repeatable, when the same person is conducted an experiment multiple times, like you are measuring boiling points of any chemical compound and you are getting the same results, then you are saying that your data is reliable. Means repeatedly you are getting the same answer. Repeatedly you are getting the same answer using the same method as well. This is very necessary that you should use the same method to get the same answer. Then the text part is how it is reproducible. The reproducible means if there are 5 students in the class and they are experimenting onto the same experiment, they are experimenting onto the same thing and they are using the same method and they are getting the similar results. So this is called repeatable and reproducible, and this is very necessary. Okay, there are 3 types of variables that obviously needs to be discussed. There are controlled variables, independent variables, and dependent variables. Controlled, independent, and dependent. What are the variables? Always in any experiment, either it is physics or in chemistry, normally the variable term is discussed in physics. Why do we use or discuss this term in physics? Because like F is equals to W is equals to mg, that we have just discussed in the previous lecture. Force is equals to weight is equals to mass multiplied by gravitational acceleration. That force is dependent upon 2 variables, mass and force of gravity. So these are their variables. You are going to put independent value of mass and independent value of gravity. Obviously gravity, the value of the gravity is fixed, but yes, let's say there is some other variable included over there, like you can say the formula for work is equals to or if you are having the formula of work, and if you are having the formula of energy or the power as well. So there are different variables. You can put any value in those formulas, but the result is dependent upon those two variables. So we are having variables normally discussing into the physics, but there are variables into the chemistry as well. For example, if you are measuring, again, let's discuss because it's an easy example. If you are measuring the boiling or melting points of any chemical compound, there are certain variables upon these melting and boiling point depends. So upon which those things depend, they are independent variables. If you are choosing to change those variables, you are open to do that. But yes, the dependent variable is, though they are those variables which are likely to be obviously get values depending upon those independent variables. So then there is a control variable. Control variable which is same during the investigation. Like if you are, let's say, pressure and volume relationship, you are discussing that pressure and volume, they are proportional to each other. The third variable, temperature, is always remains constant. So that T is control variable, and obviously P and V, they are proportional to each other. They are independent variables. The dependent variables is though they are basically, they are dependent upon independent, so they are measuring during the investigation you are doing. So these are three types of variables that obviously when you are conducting an investigation, what you are going to do, you are going to separate those variables and you are going to adjust those variables in their relevant part. Like these are the control, these are the independent, and these are the dependent. Then it would be easier for you to conduct the research or to conduct the experiment as well. Then there are errors. First of all, the random error, then there is a systematic error. Random error and the systematic error. There are other two types of error as well, but the random and the systematic errors, they are very common and they are most likely to happen. Random errors, they are normally unpredictables. Because let's say you are conducting an experiment and you are, let's say, you have a weak eyesight. You are unable to read the temperatures values onto the thermometer, or you are unable to read the calibrations properly. So obviously maybe you are reading 100 degrees Celsius as 101 or 100.02, 100.03, the calibrations are not clear to you. So these are human errors because they are unpredictable. They are likely to happen normally. So these type of errors, they are called random errors. Then there are systematic errors. What are systematic errors? Systematic errors, they happens because of the problem in the system. Let's say you are the selection of apparatus is not correct. This is systematic error. Or maybe let's say the apparatus being used, it is working not properly, it is not reliable, it is not calibrated. The calibration is very important when you are doing the experiment. Do you know that how the equipments are calibrated? Let's say you are measuring the weight of copper sulfate solid, and your weight measuring instrument is not calibrated. It is not error free. It is measuring, let's say, 1 kg as 1.5 kg. So this is basically systematic error. Then there is anomalous and zero error. Anomalous, this error is normally unusual. They are not repeatedly happens. Like let's say you are conducting a series of experiments and there are much larger or smaller, there are the differences in the values that or in the results, they are quite larger. But normally it does not happen. Then there is a zero error. Basically, it's a systematic error which is in a measuring instrument. the reading on a balance, it may not be reset to 0. For example, if you are measuring mass of or weight of any solid, because normally if you have come across to some purchase to purchase some sort of, let's say, sugar or anything, what they are doing, they are, let's say, putting it into the bag, and then they are putting it onto the weighing balance. So before putting it onto the weighing balance, the values should be 0. All of the values should be 0. If they are not 0, that, or they are showing some values, let's say 0.06 or 0.6, 0.7, let's say, or 0.1 kg even, that means it is 0 error. It is not being reset to 0 value. Clear? I hope you are not having
Yes.
any question regarding this. Let's have some video understanding upon this, because after this we are going to move towards the separation and purification things, and the filtration part. Obviously, this is going to be a very interesting part, but regarding the investigation, the part is done. Let's have a video over this. Wait. Matches up. So the closer your data is to an accepted value, the more accurate your data is. Precision has to do with if your data agrees with each other. So if your individual measurements are in agreement with each other, then your data is precise. So accuracy has to do with how close your data is with the accepted value, and precision is how close your data is with each other. So let's try this problem. So this can help you to see the difference between accuracy and precision. 4 students performed an experiment to measure the density of aluminum, and the accepted value for that is 2.7 grams per milliliter. Now let's say that the data here represents the same units. Which data is accurate but not precise?